Hello and welcome back to my channel Code with Ease by Varsha. We are doing a series on coding patterns. In the previous videos, we have discussed about the introduction and overview of coding patterns, what they are, why they are being used, what problems they are trying to solve, how they are being used. So I would highly recommend to check that out. I'm going to link it up in the description below. If you're someone who's learning DSA for the first time or is a working professional who wants to revisit the basics, I think coding patterns comes to the rescue because it gives a holistic 360-degree picture of what you are learning. So it just helps to plan the learning better. And as part of this series, we are going to cover in depth about each and every pattern, what they are, the pattern is, why the pattern is being used, how can we identify such patterns in the questions, look for clues in the questions, what is the underlying technique behind every pattern, and all of that we are going to cover. So I'm hoping this would help many of you guys. So stay tuned, and if you wish to get further updates on this coding pattern series, please don't forget to subscribe to the channel and press the bell icon, of course. So without further ado, let's jump right in. Okay, so now we are starting with the first coding pattern. So we'll talk of two pointers. I'm sure many of you would have already heard about this. It's a very basic algorithm that everyone learns when they are doing data structures and algorithm. And I think this also forms the base. It's a very basic algorithm. There are other two patterns which we are going to discuss later on, which is going to be an extension of the same algorithm. Okay, so what are two pointers algorithm? What does it mean? It's like two pointers are there, two different variables, let's say A and B, and we'll have one underlying data structure. Let's say we have an array, we can also have a string, linked list, anything. So there will be two pointers which will be pointing at two different indices of the underlying data structure. So let's say it's pointing at this index, B is pointing at this index, right? And once they're pointing at two different indexes and indices, then we do some kind of a logic to move these pointers so that they either meet each other or satisfy certain condition, and in that way just solve the coding problem. That is a basic overview. Why do we use this? Coming to the why part, this helps to improve the overall performance of the problem that we are solving. When we say performance, we mean the time and the space complexity, right? But how does it do it? How it helps? So whenever you are using loops, uh, for loops especially, and when you're using nested loops, you might observe that it is something like this. We have a for loop and we do int I equal to 0, I less than n, and I plus plus. And then inside this we have another loop, int j equal to 0, 1, whatever, again j less than maybe n or I or whatever, and then j plus plus. So the point I'm trying to make is whenever we have two nested loops and this pointer is running on every instance of the outer loop, so this gives us a time complexity of order of n square. When I say n square, I mean if the total length of the data structure is n, so whatever the length of the data structure is, it has to run twice a square of that. So n into n times, which is not a very good time complexity that we get in case of nested loops. And this is the reason why two pointers have come into picture. It usually converts any time complexity that we have in order of n square into order of n. How it does it? So you can think of it like, okay, we have a pointer I over here, we have a pointer j, and we are running this one within another. Why not? We transfer this I pointer over here at one end, and let's say we have the j pointer over here at another end. It can be at two different ends, at opposite ends. It can be at same ends also. I and j can be here, depending on the problem that we are going to solve. That is a different thing. But the point we're trying to make is instead of having two different loops and two different variables manipulating inside that, why not transfer these two variables at two different indices of that array and then move the two pointers together so that we can do the scan of the entire array in one single pass, like in one single scan or pass. Simultaneously we can do, instead of outer for loop is waiting, the inner for loop will run, then again outer for loops variable will increment. No need of doing that. So that is the underlying technique which two pointers is trying to apply. Like I said, the pointers can be at two different ends. They can move in opposite direction like this, or they can be in same ends. They can move together. I is also incrementing, j is also incrementing one by one. So in one single pass they're trying to do. Even if they're in the opposite end, then also they're trying to do in the one single pass. Now another thing what can happen is they're at same ends, but they're moving at two different pace. The speed is different. So I can move plus 2, it can do jump twice, and J can only move 1. That can also happen. So these are the different extensions of two pointer algorithm which we are going to discuss later, which is also a separate coding pattern. But this is the gist of this algorithm. Now the question comes, what are the classic examples? Let me give this example of a valid palindrome. So what is a palindrome? Let's say we have a string like this, ABBA. Palindrome means something that reads forward and backward same. So ABBA in the forward also it is same, and backward also it's same. So how can we apply two pointers? Now the point I'm trying to make is, how can we identify that we have to apply two pointers to this? The way to identify is, again, the nested for loop. So how can you understand that you have to apply two pointers? The simplest way to understand that you have to apply two pointers is try to understand the brute force way. Try to think of a brute force. The moment the brute force solution is involving for loops, involving nested for loops, you're trying to wait for a certain operation, doing it again and again. These are the indications that you can try to convert this into two different pointers. So in case of valid palindrome, we can have one pointer at the beginning, another pointer at the end. We'll check if I and j, the values of I and j are equal. If it is equal, we'll proceed. Again, we'll do the same check. The moment I and j are not equal, we'll break it. As simple as that. So in one single pass, in one single iteration, we're able to solve this. About two pointers algorithm, we'll talk of another pattern in the next video. Thank you so much for watching.